In the quiet town of Abingdon, England, behind secure glasses and sterile equipment, scientists are raising an army, not of humans, but of genetically modified mosquitoes, a new weapon in an ancient war. Malaria has plagued humanity for a millennia, and now a new mosquito species is rewriting the rules of engagement. From urban neighborhoods in Djibouti to field labs in Brazil, from quiet policy meetings to buzzing mosquito release boxes, this is the story of how science, politics, and hope are converging in one of the boldest experiments yet, which is releasing lab-borne mosquitoes to fight malaria. And if you want to dive even deeper, this podcast is based on my story in Nature Medicine. Just search for Battle of the Mosquitoes. It's a must read. I'm Paul Adepoju, and this is Paul Talk Science. Malaria used to be a rural problem. That was before Anopheles stephensi arrived, a mosquito that is native to South Asia. Now it is thriving in African cities. To understand why this new species is so disruptive, I spoke with Dr. Williams Moss, who is the executive director of the Johns Hopkins Malaria Research Institute.
It's a very wily parasite and complex vector systems that just make this disease particularly challenging to get ahead of.
According to the World Malaria Report 2024, Anopheles stephensi is now confirmed in over 12 African countries. Unlike Anopheles gambia, it breeds in urban water tanks and bites during the day. It doesn't play by the old rules. I first heard about Anopheles stephensi not in a scientific journal, but in a WhatsApp message from a colleague. He said, "This one is different, Paul. The nets are not working like they used to." To see how one country is trying to stop this new mosquito, I connected with Dr. Abdoulilah Ahmed Abdi, who is the health advisor to Djibouti's government. He's been on the front line of this crisis.
So I had a long career, and I've been working in the Djibouti Forces Medical Service, and I've been working on malaria, HIV, and many other transmitted diseases. Background: we were the team who are working on in 2012 in the pre-elimination phase of malaria in Djibouti. At that time, we had another vector called Anopheles gambia. I'm sure you are aware of that. And we knew how it was behaving. We knew that was seasonal. And after the rainfall, we knew that we will have short periods of time of malaria transmission. Things have changed since 2013 when we first discovered the Anopheles stephensi in Djibouti, which is a vector known in Southeast Asia.
Djibouti had nearly eliminated malaria by 2012. Then stephensi arrived. Malaria cases exploded from under 3,000 to over 73,000 cases by 2020.
Djibouti is a tiny country in East Africa, but that's not the biggest country of Africa. It's the way our government always in any field want to be proactive. This is how I can describe our approach, to be proactive in any field. And being tiny can't stop us on going in any direction to help our people.
Proactive and strategic. Djibouti turned to a biotech farm known more for fighting dengue in South America than malaria in Africa. That farm is Oxitec. I spoke with Frandsen, who is their CEO, and the team gave me a tour of their lab and a glimpse into their bold vision.
The malaria being spread in Djibouti is being spread by this mosquito that lives in urban areas. And if you zoom out and look at where most malaria transmission is on the African continent, in Southeast Asia, in parts of Latin America, it's normally in rural areas. Rural areas, bodies of water, and an absence of services. The malaria to date has been a rural story. And so now, as a new malaria vector enters these cities, it wants to live in and around humans in very densely populated communities. It thrives off of urban environments, and that poses a problem.
Oxitec developed a genetically modified Anopheles stephensi that only produces viable male offsprings. These non-biting males then mate with wild females, but the next generation dies before adulthood. I asked Neil Morrison, who is Oxitec's chief strategy officer, how it works in the wild.
There's nothing better at finding a female mosquito than a male mosquito. They're experts.
They call them friendly males. Released into the wild, they carry a self-limiting gene. It doesn't persist. It disappears after a few generations. But engineering mosquitoes is only half of the story. The other half, winning public trust. Back in Djibouti, Colonel Abdul told me how community engagement shaped the rollout.
It's on our own to convince and to educate and to tell what is going on. In my mind, this is the future of vector control. We have, as a scientist, to convince and to control the impact and to avoid what we call the conspiracy theory about that. We are scientists, so we have to educate and to tell the truth to the people. We are working underground, we are controlling, we are capturing the vector. Our Djibouti mosquito, when we can recapture, we know how it's lasting on the nature. Doesn't last that much on the nature. Doesn't transfer in some genetic modification to other species. There's a lot of things we have to tell to the people. That's why this is harmful, and that's not harmful. This is very efficient and sustainable for controlling the vector.
And from Oxitec's side, Greg Frandsen says the approach has to be transparent and participatory.
Our trust equation is built on being transparent. Oxitec is very transparent. We work very hard to establish a public scientific record that is peer-reviewed. We are only in locations where we have been invited. Oxitec does not go into any community where it is not invited and hosted by local government or local communities. We spend a lot of time on the ground with people, door to door, in churches, at the park, at the farmer's market, in the fields where people are. We meet them where they are, physically and conceptually. And again, we spend a lot of time just being with them, talking and educating about the technology, but really listening to their concerns, listening to questions they have very carefully, listening to the challenge they have that we're trying to solve. I could go on, but for us, there's a methodical process we use to build trust. If we can't build trust, there's no way we're going to be able to serve these communities.
But can it scale? That is a billion-dollar question. Neil Morrison says the model is replicable, but they've already done it before.
We've done it already with another mosquito, the dengue spreading Aedes aegypti mosquito. Starting with Brazil, where we launched our friendly Aedes aegypti in 2022, and we've since built the world's biggest mosquito factory, and we're now serving communities, businesses and governments right across Brazil. And as you know, Brazil is an enormous country, many, many millions of people. So we know we can do it.
And with malaria funding still below 50% of what is needed globally, according to the WHO, cost effectiveness matters.
When I'm asked about pricing and cost benefit, I think it's a difficult question to answer when anything else on the market right now is not working. So in a way, if you're paying $1 for an ounce of chemical pesticide, but it only works 20% of the time, or if you need to spend $2 or $3 on a solution that works 96 or 100% of the time, well, which one is more cost effective? One might be cheaper, but it's not working and people are dying. One might be more expensive, but it is highly effective and can save lives. There's no good answer to that because governments ultimately have to appropriate funds. They have to spend money. Donor organizations, if involved, have to make choices with limited resources. So we drive our cost down to the lowest possible unit. But because we're innovators with new products that have never been out there, it's hard to compare us to a bed net or a chemical or a trap or a drug or a vaccine, because it's very novel. Those are the things that go into us thinking through cost effectiveness.
Oxitec's team says the goal isn't just killing mosquitoes. It is about rethinking how we fight diseases in a warming, urbanizing world. Progress in malaria is stalling. Resistance to insecticides, diagnostic evasions, even the parasite itself is adapting. William Moss explained what that looks like on the diagnostic front.
We're seeing a very interestingly spread of a deletion called HRP23 deletions that make the parasite invisible to our rapid diagnostic tests. It's the only example I'm aware of where a pathogen has evolved away from a particular diagnostic test. And then we've seen, as the report highlights, the emergence and spread of a new vector in sub-Saharan Africa, Anopheles stephensi, that came from Asia, that breeds much more easily in urban settings. That was introduced into Dubai and then has spread in the Horn of Africa and in East Africa. And so there are a lot of concerns about that as being a potential vector for urban or peri-urban malaria. So a number of challenges and threats ahead of us. Those are just the biological ones.
It's an arms race, and the parasite has had a head start for thousands of years.
We're only going to defeat malaria with multiple tools. We can't do it with a single tool. Even a very good vaccine is not going to be good enough. So we're going to need to have a multi-pronged approach to defeating malaria. I think the ability to genetically modify mosquitoes, alter their microbiome, there's a lot of good research going on in these areas. I think we're still a ways away from being able to implement those. There are also a number of challenges. We have many different Anopheles species that can transmit malaria. And so targeting the genetically modified mosquitoes, that's going to have to be done species by species. We have a lot of regulatory issues, ethical issues. How do you get approvals from communities if you did a mosquito release where you can't really control them? So there are a number of, I think it's a very promising approach. We need to go down that path, but there are also a number of significant hurdles ahead.
In 2023, 608,000 people died from malaria. Most were children, and yet global investment in malaria declined. If Djibouti succeeds, it could change everything. Countries like Ethiopia, Kenya, Nigeria, and several others are all facing rising urban malaria, and they are watching closely.
We're working as fast as we can. Ultimately, it's like ours, organizations like us, are in the game to deliver impact and hopefully save lives. I would say that it has taken a decade plus to develop the genetic technology and turn it into a scalable product that is ready to go. Over the past 5 years, that's really been our focus with the dengue mosquito. Now we feel, over the past 5 years, we've felt ready to start to apply those lessons to a much wider range of pests, including malaria vectors. So it's taken time, but now we're ready to broaden the fight. This is the first release of a friendly mosquito, in fact, the first release of a genetically engineered mosquito in Eastern Africa. So we're pioneering this, we're not slowing down. And we hope to, in a stepwise, thoughtful manner, start to scale this solution really fast such that we can deliver real impact for communities in Africa.
We are in a pilot phase now. In a few months, we will come to the impact phase. What we are looking for is to decrease the population of the vector at the beginning, and then we can use the other tool. As soon as we have less vector, we will have the recovery of the sensitivity to insecticide. We can use the other tools. As soon as we reduce the population of Anopheles stephensi, then we will reduce the number of cases, malaria cases in Djibouti, and then I think the other tool will be easy to use, because at the moment this vector is challenging the public policies in terms of housing, in terms of water supply, sanitation, many things. So it could give us the time and resources to deal with other challenges while we reduce the population of the mosquito.
The most profound ideas often start small. A single engineered mosquito, a tiny country taking a giant step, a war being fought not with guns but with genes. In a changing world, we can't keep doing the same things and expect different results. In the fight against malaria, the enemy is evolving, and so must we. From mosquito factories to dusty streets, from military advisors to molecular biologists, the future of malaria control is being rewritten, and it may just begin with a mosquito. If you want to read the full story, find the feature Battle of the Mosquitoes and Nature Medicine. You will get more science, more voices, and the deeper narrative behind this episode. Thanks for listening to Paul Talk Science. Until next time, stay curious.